Yeah, students, the next code we are going to see is 4-bit adder subtractor. And here also we'll be writing the RTL code and the test bench, and we will see the output table. So before entering into the channel, please subscribe my channel VLSI with Dr. Leena. Yeah, students, now we are starting the RTL code. That is, first we are writing the module and giving the module name and opening the bracket. And then we are giving the input. Here it is. Input is data entering the module, and it is from the range 0 to 3, that is 4-bit input, and A is the first operand. And next we are assigning the next input, that is B, and this is also 4-bit input, and B is the second operand. Now we are going to give the next input, that is control. This is control signal. It decides whether the circuit performs addition or subtraction. That is, if control is equal to 0, it performs the addition, and if it is 1, it performs the subtraction. After assigning the inputs, we are going to give the output. Next, we are giving the output. In this, output means data leaving the module, and it's 0 to 3, 4 bits. The result stores the final output, sum and difference. Here the reg is used because the value is assigned inside an always block. The next output we are giving as cout and borrow. This cout borrow indicates that a cout is for addition and borrow is during subtraction. And we know reg is used because the value is assigned inside an always block. And once after assigning the inputs and outputs, we are going to close the bracket. We have closed the bracket now. After closing the bracket, we need to perform the operation. Let us look at here. Always at open the bracket, start, closing, begin. This we know. We do it for all the thing. That is, always block describes the combinational logic behavior. And this A, open bracket, star, close bracket, it means that the block execute whenever an input changes. So after giving this, we need to perform the operation. That is, this operation, if control is equal to 0, begin. This here the control, it checks the value of control. If control is equal to 0, the circuit performs addition. And let's see this. First thing is addition. Look here, it performs the addition operation, that is A plus B. This cout underscore borrow result, this is concatenation assignment. Here the cout underscore borrow and results means combine the output. After performing the addition operation, it ends the addition block. Else, if the previous condition is false, that is, if control is equal to 1, then the circuit performs the subtraction operation. Then this line you see, it performs subtraction with borrow deduction. All these explanation we have seen already in the 4-bit subtractor. And then after performing the subtraction operation, it ends the operation. Then it ends the always block, and then it finally ends the module. So this is the RTL code for adder subtractor. Yeah, students, now we can start the test bench for 4-bit adder subtractor. First we are giving the module, and then we are giving the module name. After that we are assigning the inputs and outputs using reg and wire. Look at this. First we are assigning the input A and B using the reg, and then we are assigning the input control using the reg, and then we are assigning the output result using wire and cout borrow using wire. So the first thing we are going to do is we are assigning the input and output using reg and wire. We know why we are using reg and wire. We have already clearly seen all these in previous videos. After doing this, obviously we need to do the next step is instantiating, that is bringing our module into the test bench. So we are going to instantiate the module. When we are instantiating the module, first thing we need to do is we need to give the module name which we have given in the RTL code. Then unit under test, opening the bracket, and next we will be connecting the test bench input to module input. Then testbench input B to module input and testbench input control to module input. We have connected all the inputs of the testbench to the module. Then we are connecting the result of the testbench to result of the module and carry out borrow of the testbench to carry out borrow of the module. After connecting all the testbench and module, we will be closing the instantiation. After closing the instantiation, we need to do the test cases. So initially we will be beginning, and then first we do additional test cases. There we have in the code we have assigned for control is equal to 0, we perform the addition operation. So for the addition, first we will be giving the control equal to 0, and A will be giving the value, that is 4-bit binary 0011, that is 3. And for the B, we are giving the value 4-bit binary 0101, that is 5. And after 10 time unit, we will be executing the next operation. See the next test case, that is control equal to 0 and A is equal to 15 and B is equal to 1. It will perform the operation and it waits for the 10 time unit and it starts the next operation. And you see here, when control equal to 0 and A is equal to 10 and B is equal to 5, it performs the operation and it waits 10 time unit to perform the next operation. First, we have given control equal to 0 and addition test cases are given. Now, we are giving control equal to 1 and subtraction test cases we are going to give. So, for the subtraction, we gave control equal to 1. A is equal to 4-bit binary 0110, that is 6. B is equal to 4-bit binary 011, that is 3. We are checking this test cases and it is waiting for 10 time unit and performing the next. And the next test case, control equal to 1, A is equal to 4 and B is equal to 6. And then it is waiting for 10 time unit and performing the operation of next test case. Look at this. Similarly, it does different test cases, and then we also give test cases for mixed. That is, here we separately gave addition and separately gave subtraction. Here we will be giving both addition and subtraction. That is, one case we will be giving addition and the other case we will be giving subtraction. Now look at this. Control equal to 0 means we are performing the addition and we are giving the value of A and B and testing one case, and after 10 time unit delay, giving control equal to 1, that is subtraction operation, and giving values for A and B and performing it. Similarly, the next giving control equal to 0, performing addition. And then after giving all these test cases, we finish the simulation and we end it, and finally we end the module. So this is the 4-bit adder subtractor test bench. That is, first we are going for input and output assignment and then instantiating the module. Then we give different test cases. One is for addition, one is for subtraction, and then mixed test cases. And then finally we end the module. Now let's see the output table, how it is going to come. Yes, students, we are going to see the output table of 4-bit adder subtractor. Here we have taken the 10 test cases, and first we have given the control, that is control equal to 0, we have given the addition, and control equal to 1, we have given the subtraction. And here we have given the 4-bit input A, it is in binary, and 4-bit input B, it is in the binary, and we have performed here the operation and the result, it is given in the binary, and C out borrow is given here and the result in decimal is given here. So first, In the test case, we have taken control is equal to 0. We have performed the addition operation. That is, A input is taken as 0, 0, 1, 1, and B input is taken as 0, 1, 0, 1, and its values are for A is 3 and B is 5. We have added it 3 plus 5, it is equal to 8, and the result is given in the binary 1, 0, 0, 0. This is for 8. Similarly, we have done it for subtraction. Let us look at here. For subtraction, the control is given 1 and the values are given and the operation is performed. And here we have given for the both addition and subtraction test cases. So this is the output table of our test bench for adder, subtractor. So students, if we are simulating this and if you are seeing it in the waveform, in the input we will be seeing this control and then 4-bit binary A input and 4-bit binary B input will be in the input side, and in the output side we will be having the result as well as Cout by borrow. So this we will be seeing it in the waveform window. So students, today we have completed the 4-bit adder, subtractor, and we are going to do lot more codes from the beginner level to the advanced level. So if you want to learn all the RTL codes and the test bench, please subscribe my channel, VLSA with Dr. Leena. Thank you.